Permutations and combinations are an important part of probability and being able to count how many ways things can happen. So I'm going to use ice cream as an example. When you get ice cream, let's say there's a place that has 6 flavors of ice cream. And just to be boring, they're called flavor 1, 2, 3, 4, 5, and 6. And I want to get a 2-scoop cone. And I could put flavor, oh, and in this place you're not allowed to use the same flavor twice. So one possible cone is flavor 1 and flavor 2. Another one is flavor 1 and flavor 3. Another one is flavor 1 and flavor 4. And there's a lot of different cones that can be made, but a big question is, should we count the cone with flavor 2 on the bottom and flavor 1 on top? Is that a new cone up on my list, or is that the same as the cone with flavor 1 on the bottom and 2 on top? And for our purposes, we're going to see that these are not the same thing. Maybe flavor 2 is chocolate and flavor 1 is vanilla, and you don't like it when the chocolate melts into the vanilla, but you do like it when the vanilla melts into the chocolate. However, whatever reason you have for preferring this flavor on top versus that one on top, to you it's a different ice cream eating experience. So the question then is, if these do count as different ice cream cones, how many different cones can be made? And if you start listing them, it's a lot. It's a lot of different ones. So, but specifically, there's going to be 30. And the reason that is, I could imagine this little like here I am at my starting spot, and it's like a path I'm taking. And there are 6 different, 1, 2, 3, 4, 5, 6 different flavors that could be on the bottom scoop. And then once I pick that bottom scoop, here I am, I picked 1 as the bottom scoop, so 2, 3, 4, 5, or 6 could be the top scoop, or if I pick flavor 2, I could have 1, 3, 4, 5, 6. And basically coming out of each of these would be 5 different options for the top flavor. See, this is like a sideways tree. Mathematically, I can calculate it very fast as just 6 times 5 equals 30. 6 different flavors for the bottom scoop, 5 different flavors for the top scoop. Multiply them together, because any of the 6 on the bottom could be matched up with any of the 5 on top, and any of the remaining 5 on top gives me 30. Mathematically speaking, we would say 6p2. A permutation is a selection of, in this case, of 2 things out of 6, where the order matters, meaning different order counts as a different thing. And you calculate 6p2 by doing, which means permutation, 6 times 5 equals 30. If there were 10 flavors instead, it would be 10 times 9 equals 90. And in general, I'll say np2 would be n times n minus 1. If instead of a 2-scoop cone, I now want a 3-scoop cone. So now I have things like flavors 1, 2, and 3, or flavors 4, 3, 5, and it's going to be a whole bunch of them. Well, to calculate it out, I can do 6 flavors for the bottom. Now I'm not allowed to use the same flavor twice. That leaves 5 flavors for the middle one, and now I've used up 2 flavors, whatever they are. Now there's only 4 flavors left for the top one. 6 times 5 times 4 is 120. And even if I have a large thing like 10p6, that's going to be 10 times 9 times 8 times 7 times 6 times 5. I want to have a total of 6 numbers, 1, 2, 3, 4, 5, 6. It's a big number, 151,200. Now you may have seen things like this before because there's something called factorial. When you see an exclamation point, that means multiply all the numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this is related to that. Actually, if I want to write 10 times 9, I could write it as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. These things would all cancel out. But I could write it as 10 factorial over 8 factorial. You don't cancel factorials. You expand the top one. And instead of writing 87654, I just write it as 8 factorial. Then I cancel it. That's why a famous formula for permutations is n factorial over n minus r factorial. Again, if I wanted to do 10 p2, it would be 10 over 8, which becomes 10 times 9 because the 10 times 9 times 8 factorial, and these cancel out, equals 90. So that's permutations, which are like cups. And here's a formula, and you could also think of it, I mean, I personally don't like to use this formula. I instead like to think, if you said 30p3, I think of it as just the first 3 numbers of 30 factorial. So if the place has 30 flavors, the 3 scoop cones would be 24,360, and if in Baskin-Robbins they say they have 31 flavors, 31 times 30 times 29 is going to be a big number. 26,970. Now let's move on to combinations. Combinations, if I'm putting my ice cream into a cup, whether they put flavor 1 and flavor 2 here, or they put flavor 1 here and flavor 2 here, it's the same thing to me because the order doesn't matter what order they put them in. I'll eat them. I could eat them whatever order I want, so I don't care what order they put the flavors in if it's a big enough cup and the flavors are kind of side by side like that. So when there are 6 flavors altogether, there are not 30 cups like there were 30 cones. This is using 2 scoops, but there are only 15 cups possible. I could list them out. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. I'm not going to put 2, 1 as a separate one because 2, 1 is the same thing as 1, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, 5, 6. There's the 15 different cups. Notice that any of these cups, like 2, 5, there's a cone. There's 2 different cones that have flavors 2 and 5 in them. But there's only 1 cup that has flavor 2 and 5 in it. So one way to calculate out combinations, in this case 6C2, how many combinations of 2 things can be taken out of 6, is to just figure out N6P2 and divide it by 2, because every combination, for every combination, there's 2 different cones that have that combination with 2 things. So in this case, it was 30 over 2, which equals 15. And in general, so 10C2, if I have 10 flavors, it's how many cones there are, and then divide that by 2. 10P2 is 10 times 9 over 2, equals 45. If I increase myself, though, to 3 flavors, now things change a bit. So if I have a cup with 1, 5, and 6 like that, it's like a banana split, they're side by side like that, and I don't care what order the flavors are put in. You could put in 516. That's my area code when I was growing up. However, remember with cones, 156 was not the same as the cone with 516. And actually, there's a whole bunch of cones that have those flavors in it. 165, 561, 615, 651. Notice that there's 6 different cones. So for when it's 63, I have to do 6p3, not over 2, but over 6. 6p3 is 6 times 5 times 4 over 6. So there's really just 20 different cups. So in general, when it's so like 10c3 would be the same situation. It would be 10p3 over 6, which is 10 times 9 times 8 over 6, which is 120. So NC2 is NP2 over 2, and NC3 is NP3 over 6. So the next question is, what's NC4? Well, it's going to be something with NP4, but we need to know what number goes down there. And the secret is, remember with 3 scoop cones, we divided by 6 because there were 6 different ways you could take any 3 flavors and make different cones out of them. That 6 came from the fact that if I already have chosen my 3 different flavors, any of those 3 could go on the bottom, leaving 2 for the middle, leaving 1 for the top. In other words, that 6 was really 3 factorial. And the secret number under here is going to be 4 factorial, because for any 4 different flavors, I can make 24 different cones out of those. And that's why the Baskin-Robbins questions that I like is how many, well, first of all, I'll do how many 3 scoop cones are there. It's 31p3 over 6. It's 31 times 30 times 29 over 6 equals 26,970 over 6, which is just 4,495. And if I want to know how many cups can be made with 4 flavors, I put 4 factorial under there, which is the same thing as 24. So 31 times 30 times 29 times 28 divided by 24. Well, first of all, 31p4 is 31 times 30 times 29 times 28, which is 755,160. Divide that by 24, and you get 31,465. Now, a real famous formula for combinations can be derived. So first we have this, but the NPR could be written as n factorial over n minus r factorial from before. This r factorial is this one. And when I can put these fractions into one large one. And this is a real famous formula. N factorial over n minus r factorial times r factorial. And it's a nice formula because if I want to do 30C27 according to the formula, now a trick is for reducing this to take the top number and expand it until I hit the larger factorial on the bottom, and take the smaller factorial on the bottom and expand it, cancel, 3, 10, 5, and multiply whatever is left, 5 times 29 times 28 equals 4,060. One consequence of this is that 31C2 is 31 times 30 over 2, and 31C29, using the formula, it would become 31 factorial over 29 factorial 2 factorial. And 31C29, using the formula, would be 31 factorial over 2 factorial 29 factorial. In other words, they're equal to each other. And if these two numbers add up to the number on the left, they will be equal to each other. This is using the ice cream example, because if I go in and ask for a 2-scoop cup, I'm leaving off 29 flavors. So for every 2-scoop cup that I could make, someone else could make a 29-scoop cup that has the opposite flavors. So that's the basics about permutations and combinations. 10p0 is actually the number 1, not 0. If I go in for 10 flavors and I want a cone with no flavors in it, there's one way to do that. 10C0 is also 1. 10C10 is 1 also if these two numbers are the same. Part of it's because 10C10 has to equal 10C0, but also if I have a 10 scoops and I want to make a 10-scoop cup, there's only one way to do that.